welcome. How are you guys? Welcome to the stream. So, what we're gonna do is, we're gonna build a redstone calculator. Let's see. Okay, yeah, works good. So, I've already done addition, subtraction, and screen. But I want multiplication. So I'm gonna show you how it works right now. So, for example, I go addition, I don't know, and I go with 16. I have to go tick speed 500. It's really goddamn slow. 16 plus 8, and that's 24. Or subtraction, let's go 16. No, let's go with 8 minus 2, and that is completely correct. 6. Yeah, and I just want multiplication. So I've already got the module to do some basic multiplication here, over there. If you know what I'm talking about, and if you do know about computational redstone, you probably know this thing. It's the classic Mad Wings 8 times 8 binary multiplicator. But yeah, that's good enough. So basically I have to still connect those up to the storage cell, but because you basically input over the same wires, I have like what can I show you now best? Here, those little storage cells, and once you press right here with a little right handler, it then writes the status over to those, basically. Have I got an example for that? No, not really. Yeah, it writes that to the storage cell. So even if I now cut the signal, because, well, if I then change the signal for the second storage cell over there for the second line, that changes, of course, and you see that might turn off. And yeah, it's still on because I use a repeater lock for this. So I have another storage cell over here. That is in fact the upper line, and this is the lower line. Yeah, you see, very inefficiently made, highly unprofessional, with loads of torch towers that are here connected to the display. But yeah, that works. So I just have to read the binary, put it into here, and then grab the binary, put it through, like, I don't know, some sort of making sure everything's fine. I have no idea I'm supposed to do that. But then we should have working multiplication, and I don't want to go further back. So I believe I'm just gonna stack them on top of here and bring them into there. Which is most likely the best idea, but the question is, like, how do I connect that up? Like, how? How? There's wires everywhere here. But yeah, it should be possible. Yeah, it should be, because I have a repeater every single thing here. I can just go like this and use even more repeater locks. No, it's not repeater locks, in fact. Almost messed up badly. It's a comparator cap. So a repeater lock would not work, because it would then store the result of the previous operation, which would then corrupt the correct result. I have to use observers for that. Comparators. I'm like, God, what's wrong with me? But then put them all in subtract mode, and then have repeaters facing into the comparators that are in subtract mode, just like that. And a few final times. Okay, nice. So now if I power the repeaters, every signal that is coming from here will guaranteed not pass through. And then I can just, I think that's by far my best option here. I can't wrap them on top of here. I have to bring them over here and plug them into there. It's just like that. I will tell you that. So let me think about how I'm gonna plug this in. But first of all, we have to redirect this wire a bit, because that would be too close. That would be quite annoying, in fact. Okay, yeah, that should, yeah, that works. Now I can do this. I'm not sure. I'm really not sure. Let's begin with the torch tower. So I was thinking about this little double concept here. Like boop, boop. Just like this, you see? Locks every single repeater. But then it's, I believe, can I just run the redstone through here? Even though, yeah. Yeah, I can do that actually. Yeah, I'm gonna do that. Lets me wire it up mostly simple, at least. Which is good enough. So I'm gonna take you to you. No, I don't trust you. Oh. /r stack. Yes, I used the Mad Wings mod because I ain't doing that manually. Let me tell you that. /r stack 7 up 2. Good. Now you have torches everywhere. Oop, that was one too high. No, not too bad. So, just like this. Now you see, even if I put a signal there, yeah, I just get no output. As long as that torch tower is in that state. I was just thinking about it, and I should probably put the repeater here, in fact, because I have to get the torch tower one more down, I believe. Yeah, one should be good enough. So basically, if this wire is on, that means we do multiplication, and if it's off, that means we do subtraction. No. Yeah, true. If that's on, multiplication. If that's off, subtraction. The question is, do I do the second thing here, or is this space too cramped? It probably is. Let's first get all the wires out of here. I was just thinking about something, and I believe if I go 1, 2, 3, 4, 1, 2, 3, 4, and wire it up like that, I think that in fact would be better. Yeah, that would be better. That would be definitely better. So let's stack the new version up a few times. Let's see, 1, 2, 3, 4. /r. Is it a 4 or 5? I think 5. No, but it was 4. God. Well, you'll learn from your mistakes, I guess. And then let's /save. Good. You see, now we have a lot more space to get all the wires out, you know, if you know what I mean. Which should make this entire process a bit easier. I mean, it's still pretty cramped. Depending on the fact that I have to get those signals over here. Which is, no discussion, gonna be a pain. But it should not be too bad, hopefully. Well, we have to get those over there. And then on you, but then like, or out. Yeah. I mean, should I just cross them through? I believe there was a way to do that. Let's check if we could cross them. I doubt it. If I go like that. No, that can't work. That just straight up won't work. 1 second. I know there was a way. I could do it. I could show you if I find it. 1 second though. We could watch the video together, in fact.
Across two.
So, yeah, here it is. Got it. There. You can cross them if they are offset, which shouldn't be too hard to do, in fact. Let's try that out right now. I would just bring them all one block down. Not too bad. Yeah, then it's easy to cross them. Yeah, then you can just go like that. That's not a problem then. Yeah, 'cause that works. Yeah, that works. So let's connect this also up to everything. Should I also instantly go for R stack? But the catch is, if I do R stack and then I make the tiniest mistake, I have to do it all from the beginning. Yeah, it ain't gonna be too bad. So let's copy 1 /r stack. How many? Like 4, 5? Let's go 5 up 2. Oh, that was. Oh! It was actually not too bad. Just that this is the last one where I have to do this strategy, which is good news, I guess. So here we can just normally continue our wires, but to save space I would just instantly bring them over there. I believe that is the best option, in fact. So wait, is that the real wire? No, what did I do here? Oh god. You have to come down here. You have to come down here. You come down there. You here. And you here. Finally, you get to go to the final level here. And you, well, here, I guess. Which, yeah, I'm gonna tell you that doesn't look good at all. But, honestly, I don't care in any humanly imaginable way. I really don't care. Let's extend them out. I do wire it like this. I mean, I have no obstacles up here, so I might as well just wire it like a normal human being. There you go. Good enough. Yeah, that could work. That is a design that could actually work. Yeah. So let's bring the repeater just like that. Okay. Now this should be successfully crossed in the wires. I can really hope so. Okay, looks good. Question is, do we already begin to bring them down here? Or do we do that later? Because, well, we have to get them down eventually. So, yeah, I might as well just do it here already, don't I? So, let's get you to the same block. Which would be this one, in fact. That's too light. And bring you up. Where is it? There it is. Oh, that might be a very steep connection. No, it's all one block wrong. God damn it. Ah, that's annoying. That's annoying. That's really annoying. But we're good to go. Good, now let's wire it up. I have a feeling that that ain't gonna work out that well. So let's see if that even works. theoretically speaking. So it then brings it through there. And brings it through there to the final output wire. Yes, it in fact works. And yep, it does not trigger the crossed wire. That worked better than expected. 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, that's just not gonna be enough. So let's bring one into that. Good. Second line. Bring it over there. Nope. Bring you up with as little space as possible, I guess. You see my screen, right? Let's check. Yeah, you do. Yeah, you absolutely do. Okay, good. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, it gets... Oh, that's bad. In fact, that's real bad. That's really bad. That's really, really bad. Bring you over here. So, basically, just... If you wanna know, to speed up the game, I use... Well, just slash... Tick rate. This is 1.18.2 for the mod support. Because I use mods. Or else this would be a pain on Earth to build this without mods. Let me tell you that. And so, like you see, I'm in creative and I can pass through blocks because I have carpet mod, and you can just go carpet, creative, no clip, true. And yes, in fact, see, if I land, it's still normal collisions, but as long as I'm in fly mode, I have no collisions. Just don't do anything with strip wires with this enabled, because they tweak out sometimes. They really tweak sometimes if you use them with this enabled. Let me tell you that. Let's bring this down. Instantly a repeater. Next repeater. Okay, connect this up. Could use auto dust in fact, but I think that's just gonna be worse because I'm building up. So let's just do it the old fashioned way. Jeez, what's wrong now? Just like that. That's gonna be above 15 blocks, ain't it? But I can't use torches there. Let's see if it is. It might just barely. Oh my god. The next one is gonna be a problem, however. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That works out quite nicely. So let's bring you up. Yeah, but then bringing you up too earlier is probably our best option. No. Yeah. Yeah. But I can do this once and it would still work. Okay, yep, that's the best option. So I have to bring you up too earlier. Then make one double spaced thing. And then I can bring it down, and in the double spaced thing use a repeater. Bring you down, another repeater, boom, 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 and connect it up, no problem at all. Under 15 blocks. Good, 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 good. Oh, that does look. Oh, that itches my brain that this is not off center. Anyway, this is not a funny playground. Anyway, so yeah. Yeah, we just have to do it. Sorry. It's for the functionality of the calculator, so might as well just be okay. I believe. I don't think I'm gonna add division, just so you know, because then I could get a decimal points, and this thing does not want the decimal points by any meaning, brother. It really doesn't want them. Because, like, how do you show a decimal point in binary? Like, I mean, I can show you what binary is. 1 second. And how it works. So maybe then you'll understand, if you don't know what binary is right now, a bit better. And what my problem is, you know. So basically, just so you know, this is my test world. I have a bunch of funny projects on here. Like a little screen system, and so on. Let's make a little platform so I can show you what I mean. Just like that, and let's make this, I don't know, / set white wool. There you go. Okay, so basically what you do in binary is, I think it's best to visualize with levers and signs and lamps, you know. So let's just place a binary string here, okay? So let's place one lamp, another lamp, another lamp, another lamp, another lamp. Good enough for the beginning. And now you could just put a sign on the lamps and say that's a 1, that's a 2, and that's not a 3, that's a 4. That's not a 5, as you can guess, that's an 8. And that's a 16. Yeah, this goes high. In my calculator it goes up to 128. So it's, yeah, this is long. And now let's say I wanna send the number 9, or let's say the number 10 in binary. So, well, you see, I do not have the number 10 here. Okay, I do not have it. So what do? Well, I turn on the lamp of the 8 as well as the one of the 2. You see what I get now? 0, 1, 0, 1, 0. So I get, that's the number 10 in binary. But to be more specific, it's 1010. Because, well, like, there it is. But that's 10 in binary. That's just 10. It's not 10, 10, that's just luck. Let's say the number 11, so I go 8, 2, and 1. And that would then be 1, 0, 1, 1. That would be the number 11, for example. Number 15 is everything. So 1, 1, 1, 1. That's 15. 16 is just this, and all of them off. 17, for example, so that's 16. 17 would be this. 18 would be this. 19 this. Yeah, I think you see where I'm going with this. 20 would be this. 21, 22, 23, and then, yeah, I think you see where I'm going with. You know what I mean? So basically, yeah, that's how binary works. And yeah, I think you already kind of see where the problem with decimal points and binary is. You can do it with floating point, but then I would have to completely rebuild the entire calculator to support floating point, and yeah, that's just not happening. And floating point is immensely complicated, I'm gonna tell you this already. So let's bring you up. And I mean, I could introduce division, just not with decimal point accuracy. Yeah, I could do that. But the question is, what do you need division for if it can't even show you decimal points? You know what? It's like, you know what I mean? That's also a little bit stupid, I believe, ain't it? I highly doubt this can even reach. Okay, I can. But also at the last pace of, yeah, it works, and I don't care. So yeah, let's just connect you up. That ain't gonna reach. It's close, but it reaches. So that worked out quite well, in fact, and I like that. Now here you have all the repeaters, and you can't control them because of this singular flipping torch tower. What if I just bring you over here? Yeah, I'm gonna do that. Sorry. So you have to be inverted. as well as brought over here, so I would just choose this path for you, buddy, so you don't connect up with anything else that I don't want you to connect with. In fact, not want, don't want. Okay, so yeah, that would work. Now we just have to think how we do that. I believe like this is again the best option. So let's bring the repeaters one back and you over here. But I'm not gonna do that manually, you know me. R stack 7 up 2. Is it now going to the top? Yeah, it absolutely brilliantly is. Okay, let's put all of them in subtract mode. And place another repeater here. I mean, I can do at least this manually, can't I? It would be embarrassing if I did this manually as well. Oh no. Just randomly fell out of the sky. So good. That works. Oh, that's very close, in fact. That should work on the block exact. So just like that. It's beautiful how exact. So this is why color code is good. I would have lost my mind if this wasn't color coded by now. I'll tell you that. I mean, I'm already losing my mind even though it is color coded. It's off. It's on. Oh no, that's gonna be a pain. Let's begin from the bottom where no signal is on, in fact. But let's turn them off, which I think is the best option in this case. Bring them up. Boop. Okay. And now, down here, if I place another torch, now it's on, I believe. No, now it's off. Now it's off. Okay. And this one's on. So no signal here means off. No signal there means on. I mean, that was random, but exactly what I needed. So let's just connect them up. There you go, and you have a toggle. Let's bring the toggle cable through here. So how do we get it out of here? There. This probably is the best option for us. Bring it over here. And through here. So just like that. Oh no, that's one too close, in fact. That would be a pain. So just like that. Bring them up. Good. Now you just have to somehow be able to select what kind of operation you want to do. I have an idea how the interface could look, but I have no idea how I'm going to build it. So like, I want the user to be able to select if they want to do wait, 1 second. I'm thinking how I could explain it. If they want to do a minus or addition, so like a calculation with one of those, or a calculation with a point. Okay, that actually looks, wow. It's crazy. I mean, by now it's just straight up insane how big a calculator in Minecraft is. I mean, that's the calculation part. That actually calculates. That's the display. And that's the input logic. Like, that's the display and that's the real calculator. I mean, that is kind of sad. I can show you what the division looks like. Yeah, you see. LRR. Heck yeah. I mean, come on. I can't do this on my own. I have to take inspiration from LRR. At some point, at least. 1 second. There you go. Cool. Okay. So I think my camera just fell down. I'm not sure. Let's see. It's not even starting at all. Okay, now it is. I mean, that would be okay, but it's not really good. Let's try to make it a better camera position. Let's try to position the camera a bit better. The question is, how would that hold? Okay, yeah, I think that's good. I think that's good. You still, I think, see a bit of my screen, but that really doesn't matter. How would it look if I just... sorry, a little bit of experimenting. Then you really see my screen. So it's just the light. Yeah, too bad. I'll tell you this. Like, that's the circuit you need for the vision. But, I mean, it does work, so... yeah, what do you want? I think that's A and that's B, if I'm not completely... what the flip is this? Is this like a... oh, don't tell me it is. Matt Bat, is this the vision that goes... if it has 8 inputs, we could actually work with it. It's not every single lamp off. No, every single lamp on. Weird. But sure. Do I have to like manually press something? Yeah, I have to. Okay, actually, what is this, MatPat? No, every single lamp is on. Funny, I guess. Okay, so let's go with 1, 2, 4, 8. You know it. 8 divided by 2. That should be 4, let's say. What is happening? 1, 2, 4. That is absolutely correct. That is insane. That's like probably the slowest but also compactest division. And I just realized, 1 second, yeah, it goes up to 100. Yeah, I could implement that because my entire calculator works on this binary principle. Every single number transferred to the calculator uses exactly that many binary integers. Yeah, I think that's pretty cool. Oh, I could. Yeah, I guess. I have an itch. I have an itch to do it, in fact. I really have an itch to do it. Yeah. I'ma just pause the stream here for a second and be right back with you. So let's see if I can get you guys some music on. So, bye-bye. I'm back. So, let's get cooking. Music, bye-bye. Because I'm back now. You don't hear music, hopefully. Yay! Hi. So, that's mad bad. No, we wanted this. So, anyway. We could... I just saw it. That is definitely not supposed to look like that. How it's supposed to look? Let's take a look. How it's supposed to look. It's supposed to have a lot of redstone on top of here. That's really bad. Oh no. Oh no, oh no, oh no, oh no, oh no, because my schematic only went to up here. Oh no. I have an idea, however. If we just take a screenshot, open it up. Okay, here you got the screenshot. And then go back into the world. And then pull the screenshot up. As well as Minecraft. Minecraft not in full screen anymore, but rather here. There you go. And now you can kinda like rebuild it painstakingly, but better than missing. So redstone, repeater. There comes this. Behind that you need that. Block right here. And 2 0-tick repeaters facing into the void. Sure. And some redstone wires all around here. Into here. The redstone is placed like that. Comparator, minus mode. Let's go boop. A Tochi. Redstone. Just like that. Another piece of redstone here. How does this redstone look like that in his build? Because here is another torch. Oh my god, that's evil. That's evil. Okay. And here is still some more things. We have a target block, out of which there is this blue line that has 1, 2. Comparator this, comparator and subtract mode. Boom, and connect that up. Have I now completely rebuilt the upper part? Let's hope so. Let's really hope so. Good enough. So, now that we have fixed this, it still doesn't explain why it does that, in fact. Well, what am I inputting into this? That's of course wrong. Still doesn't bring it down, because I have to, of course, press clear. Okay. Oh, true. How do we know that it is time to calculate? I have an idea. Yeah, I think we're gonna go with that idea then. Okay. Yeah. Let's first of all finish connecting. Where were we? I think we were here. Yeah. This circuit. Yeah, we're gonna do that later. Did I finish everything here? Yeah, I think I actually did. So yeah, then it's time to painstakingly grab those 4 wires and plug them into there, while keeping space for this. How the okay. First wire already collides, great. Bring it all the way over here. Plug it in to there. So let's go with repeater 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's start live here from 6. Oh yeah, that's not gonna work, ain't it, huh? So let's take a repeater here. Good. Second line. Why are you coming in that high? Sure. Oh, I already see the problems arising with this design. Oh well. Too bad. I don't care at all, honestly. Just slam some repeaters into there. Why would I have to do this manually? What, that could actually work out? Yeah. I can give this repeater away. Okay, is that true that the second one is on? Yes. So you're the third one, huh? And what do you think I'm going to connect you up? Yeah, I don't know either. Bring you over here. And plug you in. Nice. Ah, it actually comes together. Slowly but steady. Good. Yeah, that won't. Is it? Yeah, for sure not. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. No. Just no. Thank you. We have one more. Which is just... it is doable, in fact. If we go like this... No. Still not. And like, we can't use a repeater here, of course. What we can do is this and pray. I mean, we can... Why are we even trying to guess if it would work out? Just turn the wire on. Yeah. More than enough space left, bruh. Okay. And the last one, the hardest one. To wire... I guess it's gonna be the hardest one at least. So let's bring you over here. Where do you have to plug that in? Here. Okay. Bring you up. That's not wired nicely, but it works. So I don't care at all. Wire it all up. I mean, yes, it's kind of limited in what calculations it can perform. But come on, it's built in Minecraft. What do you want? So, yeah, that's wired up now. That's quite nice. So theoretically speaking, we could already test it, huh? Alright. Yeah, we should be able to just straight up randomly test it. It's gonna show complete random nonsense now. But come on, who really cares at all? So let's go... 2. Tick rate, 500. 2 times 4. That's 254. Oh, because it's 2 minus 4 and then it overflows, and yeah. So that's correct because it's a 200 blah 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 bit overflow. There you go. I know, I'm very professional. So yeah, you have 2 and 4, so let's press the button. Let's see what it outputs. 1, 2, 4. Right! That is exactly correct. And does it bring up the signal number 8? No, it can't because of the singular block there. That almost ruined the entire project. And it outputs the number 8 as well, right? 1, 2, 4, 8. Yes, it does. So the multiplication part itself is absolutely working. Now we just have to somehow automate it, but that should not be too hard. Hopefully, maybe. Let's see, because that's the clear button. Like how do you automate a clear button like that? It's insane how quick this goes. Can't I just like with some... I can't bring it around here, so I probably have to pull it through there. But then it would be the farthest block out, won't it? Because that is the farthest. No, it's not. Except from the display wood. Okay. Just pull it down here. So if I go like this, would this still work? Theoretically speaking, yeah, it absolutely would. Nice. So this is now our reset, and I think we should just call the reset before each calculation occurs. So let's just pull it around here. That actually goes another block earlier. So we have to power this with a repeater anyway to perform the calculation. And the thing, because it, yeah, as you can see, Redstone needs a really long signal to work. How do we do that? How do we do that? I have an idea. So here is the input signal. Now let's put it somewhere else. Or at least a bit further away. So here is the input signal. And what the input signal does is it goes right. Right is this little machine. You probably know what it is. It just makes redstone signal really long, no matter how long the original one was. And then this signal gets plugged into here and pushed up there. But what we also do is, well, the calculation needs to be performed delayed. So let's push all of that in delayed, I guess. And with that, with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And almost instantly we push it through. Nice. So this is now our new calculate signal. The question is, how do we get this signal? How do we get this signal? I have an idea on how we could get it, but that's really unoptimized. But do I look like I care at this point, honestly? As long as it works, I don't really care. No, that's one block too close. Let's bring it down here. Is that the lowest part of it? Yeah, it actually is. Funny. No, it's not. No, it's absolutely not. Good. So let's bring you up here, I guess. Well, the question is, where do we plug it in? And the answer to this question is here. Okay, actually, how? No, like, actually. That's like quite a long wire, in fact. So let's pull the wire up to its location. Here you go. Here is the long... Yeah, I don't want to call it a highway, but like where the wire is gonna be. Plugged up. Oh, you can do it like that. Good. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You could do 15, but I always do one block of reserve. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12, 13, 14. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Good. That worked out perfectly. Oh my god, yes. So now the multiplication would theoretically return. The question now is, we have subtraction selected here. Yes, we have subtraction selected. And we have in the subtraction itself. That's really creative, but not supposed to happen. Oh, it's not powered. Okay. Well, that's wrong, I believe. Because I don't want to do subtraction, I want to do multiplication. So, multiplication, please. Now it should unlock the multiplication and lock the subtraction. Good. The multiplication part knows what it should be doing, so I think we should go for a round in real time, huh? So let's go /tick rate 24. That's all real time now, okay? Nothing is sped up here. This is how fast it would run if you were to actually do it in your world, okay? So let's go 4 times 2 and see how broken it is. 4 times, come on, 2. And that is what? It worked. It actually worked. Okay, yeah, that's kind of cool. In fact, that is really cool. It can't multiply now. Oh no, how we're gonna wire this? It's already janky. Hey, but the multiplication part works, you know. I think we should now just this little connection wire. Let's pull that back to its origin. Should I wire it blue? But then it is like obvious what it is, you know what I mean? And it's really obvious what it is. Let's first connect it up. Oh, that's dangerous. I wonder. I am actually confused, but this has never flipped any of the calculations of this thing completely. But sure. So, is that gonna work? If I put a repeater there, yes. But then that's too far for sure. That's too far. So anyway, let's go /autodust and just pull the wire. All the beautiful way over here. 1 second. So there you go. Pull the wire. Oh, like how many wires does one calculator even need to function, bro? Okay, good enough. So here is where the logic is gonna be. So let's go with 1 repeater here, 1 repeater here, 1 repeater here. Oh, I don't know, like, yeah, it's got another one very close. But then we can have some optimized wiring. Why did I even think this was gonna work, huh? So. Okay, bro. This calculator, at this point, just has way too many wires. Just way too many that are connected to the control room of it. But I mean, it has even more wires that it uses to calculate, so I think it's quite fair. If something was horrible for me to do, it's gonna be horrible for you to use. End of discussion. So, how do we do this now? I think we should then make a tunnel. On equals do 1 second though. I have to look something up. I have no idea. Okay. There you go. On equals tallying. Off equals multiplication. Because if it's off, it's gonna do multiplication anyway. Yeah. But for this to work, you would have to do this. Good. Now you can connect it all up. This block here, let's hope. So I think I did off equals multiplication, which means I just have to simply do this, which, yeah, off equals multiplication, good. No, I think flipping it over there is a bit stupid. Let's flip it directly here, then as well as this piece of technology. Why did I even delay it? What did I think when I did that? Now I should be able to flip it instantly. Rather instant. Let's say rather instant. Good. So now if I'm, even if I'm in addition, and I oh no, we're gonna ask if it's the lever or the lamp. Off equals multiplication. You sure about that? Yeah, cause that's bullshit. Off, cause right now it's doing addition. So I have to, like, in this state, it should do something else, of course, we know that. Let's go for, how do you wire something like this? It's so compact. Like, you see my problem? Bring it up there. So right now, it's doing tallying. And now it should be doing multiplication. Yeah, it absolutely is. Okay. So let's see if it's really doing. Let's go 8. Now you can bring up the tick rate again to 500. 8 times 2 is 16. This thing is so incredibly cool. Okay, so like this circuit works. Like it does really work. And it's also, and sends it to the output lines, and like, just so you know, the output lines are really just hooked up to a really large read-only memory that takes binary and then outputs into the specified line, like the number, you know what I mean? Like, that's really all it does. So let's go tallying again. So yeah, that's fine. The thing is that we have to make this somehow support multiplication, this little sign here, which is just not possible in a normal way. We'd have to rewire everything, huh? Yeah, really would. Wait, so on is plus, off is... Oh, we can't even use on-off anymore, huh? So let's break this all down, and first mark with little blocks every single thing that we have to be able to control. Really? 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 Great. So that's really just what we have to power for plus. Right. Or do we do this for multiplication, just a single lamp instead of an X? Because this is how it would be in real life. Yeah, I'm gonna do that. I'm gonna use this. What now? So now we have to control the side ones. Like that means we don't have to control those anymore, which makes this all a bit easier, you know. So blue is the multiplication one. Orange is plus, so for plus we have to go like this. This is what plus should do, as well as pump a signal into the top one. If I can get this wired up somehow. Yeah, I can. Good. This is what plus should do. Wait, let me think. No, because we have to bring you down and then back up. Just like this, and then you can wire this up. In a nice and fancy way. Now I can break this block. So this is plus. So in theory, if I just go like this with like 2 wires, I should be able to display a plus. What is this doing? Oh yeah, of course. Yeah, that all makes perfect sense. That makes perfect sense because I messed up some of the wiring. But those artifacts are funny, I would guess. Yeah, same issue as before. So let's just put glass there. Just like that. Wait, no. Which means that it can't connect to this repeater. I'm just gonna ignore it. At this point, I might as well just ignore it. But like, how can I then power this one? Yeah, like that. Now it's just the bottom one that I forgot to hook up in any way possible. Great, because this one's secretly also the hardest one to wire up, so yay. So let's use like this kind of glass structure. Yeah, and we have a plus. Nice, and if I now trigger you, I should have a decimal point. Next up, how do we display a minus? Because a minus is the green wire. That probably should come in round about here. Okay, this is gonna be hard. I feel it already. Okay, so to display a minus, we have to let me check. That won't work. That really won't work, huh? Then let's first go like this, as well as this. Wait, no, this also won't work because of this. Bro. Let's place the dust here. Dusty crusty. Like, we have to somehow separate those, you know what I mean? So that you get powered from like over here, maybe. Just like that. Okay. Yeah, that should work now. Now we should display 1 pixel. Good. The middle one is rather easy. It's just like that. Now we display 2. And like 1 final pixel. Like, how do we do that? In fact, I do not have a clue. Like, then we have to wire you for the... What if I wire you like this? What do you say about this? So let's quickly turn on the plus again. Would work, but now the bottom one is broken. Because it needs this. Which of course won't work. Because it just... I mean, yeah, display a plus now, yay. No, that's not what we want. It has to be displayed at the same spot. So how can I else reach this one? I can go up to this one just a tad higher. Because then... No, I have to go up to this one a lot higher. While still not doing this mistake. No, because that will then also power into this one. So I have to go up to this one like that. No, that then doesn't display this one. Now it does. But this doesn't work. So let's go like this and like this. Now we have an artifact here. Yeah, of course, because that powers into this block, and that just doesn't want to work because, like, yeah, no, that's QC, and we don't want that. How can I stop the redstone? Can I place sand here? Because I don't think it would do the same. Okay, it would do the same with sand, in fact. If I break this, yeah, but then the top one still works. We get no artifacts. Yeah, that's what I want. That's what we want. And now it's rather simple, in fact, to connect to the bottom one via something like this. Oh no, repeater, redstone block, redstone. Yeah, now we have a plus. Okay, that works. So let's turn the plus off. Let's check if the decimal point still works. Decimal point still works. And the minus. Oh, now the minus triggers the top one. Really interested why. Oh, absolutely see why. Huh. Which means we can break that anyway. Because that means that we power this like that. And then the minus can't reach this because of... Okay. Yeah, but that at least makes sense, you know what I mean? That just makes sense. It's annoying, but it makes sense, so I have to live with it. What if I make a bridge like that? To connect up to this one? Then, now we trigger the bottom one as well. How are we able to trigger the bottom one? Because this piece is activated. Because we pump in it with a thing. Bam. But then this won't connect up, of course. So we have to do this, but that also means we have to remove this. But the bottom one is only activated in the plus, so that should actually work out. 2 dots. Plus should still work. No, now the top one is missing. Yeah, of course. We have to, using glass, very important, bring you up. Yes, now you can disconnect that, which makes the plus even worse. Great. Because it's glass, it can't transfer a signal downwards, of course. Thank you, Minecraft. Now we have a plus. Plus works. Decimal point works. That's really just a minus, huh? It really just a minus B. Because the minus now, of course, also activates the top. Like that's included in the package of not so nice things. Which means you have to wire you from one block further down. But of course, then the plus wouldn't work, because then the bottom one could not activate. No. Why does the bottom one still work? Yeah, sorry, the top one. the top one doesn't work then. And this is also only activated. I mean, that has to be possible. It has to be. It can't be that hard. It really can't. If I pump this with an observer, with a repeater, not observer, sorry. Just like this, maybe. No, that won't work. Because it's glass and then the, yeah, that make total sense. That make total sense, yeah. But I don't see no other way. Wait, I think I do. And the way is this. No, we get an artifact here. Yeah, because of this block. We were at this point before, weren't we? That we get this artifact. Why am I even putting a block there? It works. Like, what do I want? It really works. So we got the decimal point, and now we just have to finish the minus, because I think that one still doesn't look good. Decimal point? Yeah. Minus. Yeah, the minus still ain't still only 2 blocks. That just messes it all up for me. What about now? Minus is 3 blocks. Decimal point is a standalone. And plus? No! No, plus can't connect. Because of this? Okay, we got the plus. We got the plus. We got the decimal point. Yes, we do. Please minus. Please minus. Please, little minus. Yes. It's all connected up. Ladies and gentlemen, we have done it. We can now, just with those 3 identical redstone wires, we can control which signal of operation we want to display using this monstrosity of a dangerously wired thing. But, like, I don't care at all, it works. So this is the input of addition or subtraction. But we have to make a second input, of course, for, well, multiplication. So let's just go like that. Bring you up. I'm butterfly clicking so hard right now, no? So let's bring you over here. Torch. You know what? No, I'm not doing that manually again. For what would I have world edit? And redstone tools are stack 1 forward 2. There you go. It's all connected. Oh no, maybe not. Now we just have to grab again if we are doing multiplication from, I reckon, round about here. So now, if this is on, we are doing multiplication, right? Yeah, if this is on, we're doing multiplication. So if this is on, it goes all the way through here. Oh, come on, all the way up here. Cancels this one. Because right now it's on. That means we are doing addition, I believe. Yeah, we're doing addition. Okay. So it's just like wiring. More simple wiring like this, is it now, really? I mean, everyone should be able to wire that who has used redstone before. And final wire. Pull it all the way up. Come on. Come on. Come on. Okay. Yeah, nice. It is showing a plus. So let's go tick speed. No, tick rate 20. Subtraction. It goes decimal point now. That's interesting. Yeah, of course, I messed up with the wiring. Which is now really a bit embarrassing, but it can happen. Okay. Joe minus. Whoops. Yeah, minus. Plus. Plus. Again, let's switch to a minus to see if it still works. Yep. And let's go decimal point. I think the decimal point wiring doesn't work. Huh? It really doesn't. Because I've now switched into decimal point. Yes, I have. You can see the... Oh, because it needed a repeater there badly. Okay, now it should. No. Why not? Wires down. It's brought over here. All the way up, all the way up. Come on, come on, come on. It's here. Turns this one off. Which it doesn't. Oh. Oh, that's interesting, however. Yeah, that's really good that I saw this. I have to go like this. And now it's decimal point. Okay. I actually messed something up with the calculation. Let's go a minus again. Minus. Let's go a plus. And a decimal point. Nice! It can now display every type of calculation, and it can even do it. So theoretically, now that it says decimal point, and I go 8. Oh, I already had that one. Then let's go something which I don't think it can do, but yeah, you never really know. So let's go 8 times 4. See what I mean? Like a little bit of a larger number. 32. Let's see what it says. Come on, give me the 4. Okay, and now display my result. 32. Yeah, that's correct. It's so cool. Okay, so it can now officially multiply as well. Nice. But the catch is I don't even think I am going to be able to connect division up, you know what I mean? Like I've already got so many gates to handle what gets sent to the result. I mean, if I would do division, I mean, it would be nicer to have it here. Well, this is like the input and this is the main part of the calculator, as you can probably see. Okay. I mean, now multiplication works, so that's nice at least. That's really nice. Yeah, but I think that's about all for the stream. We have completely implemented multiplication in the stream, working as well as set up the control and completely rewire the display for the signs what it is calculating. Good. So I guess this is it for the stream, and I'll see you next time. Bye bye.